Today, I am going to discuss Kc and Kp for the dissociation of dinitrogen tetroxide. In this lesson, we are going to learn significance of Kc and Kp for the dissociation of dinitrogen tetroxide. So, let's begin. Kc and Kp for the dissociation of dinitrogen tetroxide. Dinitrogen tetroxide. When dinitrogen tetroxide is heated, then it dissociates to nitrogen dioxide. When the reaction is balanced, then we get 2 here. Now let us see what is Kc and Kp for this reaction. Suppose dinitrogen tetroxide is taken here a mole, and the volume of the reaction, the volume of the flask in which this reaction is conducted, suppose this is V liter, then we can write here at the initial stage when time is 0, then this is a mole and this one will be 0 mole at 0 time, but at equilibrium some amount of dinitrogen tetroxide converted to product. Suppose this is alpha mole, then remaining number of moles of dinitrogen tetroxide is A minus alpha mole, and here alpha mole, 2 moles of nitrogen dioxide is formed. That is why this is 2 alpha moles. Now let us see concentration of dinitrogen tetroxide. Number of moles of dinitrogen tetroxide A minus alpha divided by volume of the reaction flask, mole per liter. Then concentration of nitrogen dioxide, number of moles of nitrogen dioxide twice alpha divided by volume of the reaction flask, V, mole per liter. Now let us see Kc for this reaction. Kc, equilibrium constant in molar concentration. Kc is equal to, we can write according to law of mass action, concentration of nitrogen dioxide, here 2, this coefficient 2 will be used as power, divided by concentration of the reactant, nitrogen dinitrogen tetroxide. Putting the values of the concentration of these components, we get concentration of nitrogen dioxide, this one, twice alpha by V square divided by concentration of dinitrogen tetroxide, this one, A minus alpha divided by V. This is equal to, we can write 4 alpha square by V square. Now this term is inverted, V by A minus alpha. Now this V will cut this square, then we can write Kc is equal to 4 alpha square divided by V of A minus alpha. This is Kc for this reaction. From this equation we can say that Kc is dependent to the volume of the reaction flask. That is, Kc increases with the decrease of the volume of the reaction flask. This is the significance of Kc for the reaction. Kc is equal to, we got 4 alpha square divided by V of A minus alpha. Kc is dependent on the volume of the reaction system. From this equation, we can say that Kc increases with the decrease of the volume. This is the significance of Kc for the reaction. Now let us move on to the Kp. Now let us see what is Kp for this reaction. Kp is equal to, we can write according to law of mass action, partial pressure of the product, that is nitrogen dioxide. Here this coefficient 2 will be as power, divided by partial pressure of the reactant, dinitrogen tetroxide. Here partial pressure of nitrogen dioxide is equal to, we can write number of moles of nitrogen dioxide twice alpha divided by total number of moles of the components in the reaction system, that is A minus alpha plus twice alpha into total pressure of the reaction system is considered P. This equal to, we can write twice alpha divided by A plus alpha into total pressure. Now partial pressure of dinitrogen tetroxide, this equal to, we can write number of moles of dinitrogen tetroxide A minus alpha divided by total number of moles in the reaction system A plus alpha into total pressure of the reaction system. Now putting the values of partial pressures of these components in this equation, we can write partial pressure of nitrogen dioxide, this twice alpha by A plus alpha into P square divided by partial pressure of dinitrogen tetroxide, this one A minus alpha divided by A plus alpha into total pressure. This is equal to, we can write 4 alpha square into P square divided by A plus alpha whole square into, this term will be inverted, that is this one will here A plus alpha divided by P of A minus alpha. This P will cut this square, then this one will cut this square. After that we can write 4 alpha square into total pressure divided by A plus alpha into A minus alpha, that is A square minus alpha square. This is for Kp for this reaction. This is for Kp. From this equation we can say that Kp is dependent on total pressure, that is Kp increases with the increase of the total pressure. This is significance of Kp for this reaction. Kp increases with the increase of the total pressure. This is amount of substance that converted to product. If it is very small, if it is considered negligible, then A square minus alpha square is equal to, we can write A square if the value of alpha is negligible. Now from this equation we can write Kp is equal to 4 alpha square into total pressure divided by square. From this equation we can write, after cross multiplication, alpha square is equal to a square by 4 into Kp by total pressure. Then alpha is equal to, we can write, a by 2 into root over of Kp by total pressure. Alpha, amount of substance that converted to product. This alpha is equal to a by 2 root over of Kp by pressure. That is, amount of substance that converted to product is inversely proportional to the square root of the total pressure of the system. This is for alpha. Amount of substance that converted to product is dependent on the total pressure, and it is inversely proportional to the square root of the total pressure. This is all about Kc and Kp for the dissociation of dinitrogen tetroxide. No more today. Thank you very much.